My name is David, and this is my UML and flow diagram for the slot machine exercise. In this assignment, we were asked to develop a UML and flowchart diagram to model a given program and then describe how we developed our model. So before we begin by explaining the UML diagram and flowchart, let me run you through the code. The program contains three files. The first is the header file, where the class slot machine is declared. The second is the slotmachine.cpp, where the class is implemented. And the third is the main.cpp, where the program that uses this class is implemented. Over at the header file, we have a class slot machine with a group of private and public attributes and functions. Because the name of the class is slot machine, I named my UML slot machine as well. The UML diagram has a box for the attributes and the functions of the class. So let's begin by identifying what attributes the class has. It has an array of ints, reals of size 3, and two int variables, num symbols and spinct, all of them private. We indicate their accessibility type by a minus sign to indicate the attributes as private. We then have the name of the variables followed by a colon and their type. To fill this box, let's look at the functions or the methods of the class. This is easy as methods always have parentheses after their names. We start by having four private functions that we can put in the UML diagram, preceded by a minus sign, followed by the name of their functions and their return types. On the public box, we have the two constructors, one that receives no arguments and is implemented inline, and the other that receives num symbols as a parameter. Then we have five more public functions that are preceded by an addition sign, because they're public. Four of those do not modify any state of the object, so they have to have the word const, and this is shown by the word const. And that's our UML diagram for the class. Moving on to the flowchart, the way I created it was by going through the program step by step and adding the shapes as I went. So let me walk you through the code and the flowchart step by step simultaneously. We start at main.cpp, where we create an instance of the class slot machine called ladyluck. Creating this object calls the noarg constructor, which is implemented inline in the header file here. The implementation calls the setNumSymbols function of the object with an argument of 10 and sets spinct to 0. Now, setNumSymbols sets the random number generator seed to a new seed and sets the private attribute numSymbols to the argument received. Now we come back to the first flow and call two functions of the object ladyluck, pullLever and display. In the same way I added the color to the constructor box, I added colors to both boxes to signal where to look at in the diagram where these functions are as well. The first function called is the pullLever function. The function assigns a random number between 0 and 9 for each element of the array reals. Then it increases the spin count, spinct, by 1. After it terminates, we go back to the flow and a second function, display, is called. This function simply outputs the three elements of reals in a rectangular formatted box. Now we run into a while loop. For the while loop, I used a diamond to represent the loop condition. While the ladyluck.isWinner is false, we call the pullLever and display functions once again. If not, well, we simply break out of the loop and we output u1 in, and then the number of spins it took. Inside of the output, we call the getter for the spinct value to show how many times the player pulled the lever. Back to the loop, we call the isWinner function, which returns the output of the OR Boolean operation between the values returned by the 3-of-a-kind and straight function. When the 3-of-a-kind is called, it sets the Boolean variable win to false. Then we simply have an if statement that sets win to true and then prints the caption 3-of-a-kind if all the elements of the array match. Then we simply return win. The other function it calls is the straight function that returns true if the elements are consecutive by 1. Now, after both functions return, the program goes back to the flow to print the output and complete the program. Thank you for watching.